We're going to pick up with question 5 from the Matrices review. Question 5 says, I have the matrix A, which is 2, 1, 8, 5. Part A of this question would like me to find the determinant of A. In order to find the determinant, I have to use my my multiplication here. I have to do 2 times 5. I have to multiply my leading diagonals, 2 times 5. And I have to subtract my other diagonals when I multiply them, 8 times 1. So I multiply going down here first, and then going the other direction. So 2 times 5 is 10, minus 8 times 1 is 8. When I subtract, I get the number 2. So my determinant is just the number 2. That's it for part A. For part B, it wants me to find my inverse. And in order to find my inverse, I have to do 1 over my determinant, which is 2. And I have to multiply that by my adjugate, which is my flippy matrix. So in order to do my flippy matrix, I'm going to use the same pattern here. I'm going to take these diagonals, and instead of multiplying them, I'm going to switch their position. So I'm going to have 5 and 2 instead of 2 and 5. Then my other diagonals, instead of changing their position, I'm just going to keep them where they are and change their sign. So I get a -1 and a -8. So I have my adjugate to multiply by my determinant, 1 over my determinant. And this is going to give me my inverse. So all I have to do is use this 1/2 scalar, multiply every term inside my adjugate by that. So my new matrix is going to be 5 over 2, -1 over 2, -8 times 1/2 is -4, and 2 times 1/2 is just +1. This is my inverse. Now for part C, it wants me to find A squared, which remember is not just squaring every element inside A, because I have to follow the same rules for multiplication that I do in every other multiplication type problem. So I have to take my A, 2, 1, 8, 5, and I have to multiply it by itself. So in order to do that, I need to do the finger thing. I need to multiply across and down. So I'm going to start over here, 2 times 2, that's going to give me 4, plus 1 times 8, which is just 8. I'm going to move to my next column. 2 times 1 is 2, plus 1 times 5, which is 5. I'm out of columns, so I move to my next row and start again. 8 times 2, 16, plus 5 times 8, which is 40. And I have 8 times 1, which is 8, plus 5 times 5, which is 25. So all we have to do to finish this guy up is just simplify. So I have here 8 plus 4, that's 12. 5 plus 2, that's 7. 16 plus 40 is 56. And 8 plus 25 is 33. We are all set with problem 5. I think we've got time to move on to problem 6. So let's take a look at problem 6. Problem 6 is very similar. Problem 6 says A is 4, 5, x, and 3, and they've given us the determinant of A is 2. Now, the first question they are asking is us to find the value of x. So they gave us our determinant this time, and now we have to find a missing variable inside of our matrix. So let's use the information they gave us about a determinant. Our determinant was 4 times 3 minus whatever x was times 5. And that determinant was the number 2. So we're going to solve it like an equation. So let's simplify this. 4 times 3 is 12, minus 5x should be the number 2. So if we subtract 12 from both sides, we end up with negative 5x equals negative 10. And we can divide both sides by negative 5 to find out what x is. So x is going to be positive 2. So now we know our missing variable is the number 2. For part B, it would like us to find our A inverse. So in order to find our A inverse, we're going to have to do 1 over our determinant, which was the 2 that they gave us. And we'll have to multiply that by our flippy matrix, our adjugate. So in order to do that, we're going to have to take the number 2 here. We're going to have to know that that's a 2. So we're going to have to flip the places of our leading diagonals, 3 and 4 instead of 4 and 3. And then we'll change the signs on our other ones. So we have -5 and -2, now that we know that this x is 2. So the final step for our inverse is to multiply every element inside by this 1/2 scalar. So we end up with 3 over 2, -5 over 2, -1 because we had 2 over 2, and 4 over 2, which is a +2. There's our inverse. The last step for this problem, part C, is also asking us to square A. So C is asking for A squared. And A squared, remember, is not just every element inside A multiplied by itself. Rather, we have to do our matrix multiplication technique, which uses that finger thing. So we have our two matrices side by side. We're going to multiply the elements inside. So we start with 4 times 4 plus 5 times 2, 16 plus 10. 4 times 5 plus 5 times 3, 20 plus 15. 2 times 4 plus 3 times 2, 8 plus 6. And 2 times 5 plus 3 times 3, 10 plus 9. And when we simplify this, we get our final answer. 16 and 10 is 26. 20 and 15 is 35. 8 and 6 is 14, and 10 and 9 is 19. And that does it for question 6. We're going to pick up with question 7 in the next video.